And question 3 is all about the inequalities. The first one is a nice linear one, because when you multiply that all out, you'd still just get x's, you wouldn't get x squareds. So this one will be really easy. It'll just solve like an equation. We'll do that first. So for a, I'll multiply the left hand side out, so you get 3x minus 6 is less than a minus 2x. If it was an equation, you take your x's over, so 5x, keep the inequality the same way around, and then 8 plus 6 will be 14. So x is less than 14 over 5, or as a decimal, 2.8. Underline it so it's clear. So that is part A. Part B takes a little bit more work. 3 marks. What's really nice, it is a quadratic one, so we have to do an extra bit at the end, which we'll talk about in a bit. But it's already factorized for you, and that's why it's only given you 3 marks, because it's done the hard stuff for you. So if it was an equation, you would have x equals 7 over 2 and x equals -1 if this was a quadratic equation. However, it's not. So these here are what's called your critical values. And we need to decide if it's going to be less than, greater than, less than, greater than. And the way we decide is to consider the graph. And the graph is just a quadratic graph. It's a parabola. And the critical values tell us that it crosses at 7 over 2, which is about here, and -1, which is about here. And it's a positive x squared graph, positive parabola, like that. And why we draw the graph is because, if I change colour, blue, we want to know when this bit here, this function, when it is less than 0. So when it's below the x-axis. When is this function less than 0? That's this bit here. And you can describe that bit. It's when it's greater than -1, which we can't see anymore, or when it's less than the 7 over 2. So we can describe that using inequalities by saying x has to be between -1 and 7 over 2. So that says x must be greater than -1 and less than 7 over 2. That's the only place where this function is less than 0 below the line. So we'll leave our final answer in blue. You don't have to write in blue. Underlined like that. Part C, let's go back to the black. We have to find the set of values for which both this and this are satisfied. So part A and B. It's sometimes good to think about a number line if you want. We've got x has to be less than 2.8. If you just consider a number line, we've got -1, 2, 0, 1, 2, 3, 4. Let's continue that. So for this one, x has to be less than 2.8. Yeah. So x has to be less than 2.8. So anything before 2.8, that's fine. If we consider the blue one, I knew there was a reason I did blue. If we consider this blue one here, x has to be between -1, that's here, and 3.5, 7 over 2. So that's here. Oops. And what we want to know is the set of values for which these two are satisfied. So when are they both satisfied? Well, they're both satisfied anything from here all the way, and this black line goes on forever, remember. Let's make that, because it's less than anything less than 2.8. Change back to red. So when are they both satisfied? Anything from here up to here. It has to stop here because that's when this blue line stops. So for part C, we'll stick with the red theme. The set x has to be between this point, this point. This was -1, and this point was the 2.8. That's the only times where they're satisfying both this and this. And that's how many? 4, 6 nice easy marks there.